Okay, for our partial pressure example, we're going to look at some partial pressures of different gaseous components of air. So a good estimate for the composition of air is 78% nitrogen, 21% oxygen, and 1% other stuff. And when I say mostly argon, I mean it's like 0.94% argon, and then 0.04% carbon dioxide, and then a bunch of other teeny tiny concentrations of other things like helium and stuff. Okay, but that's irrelevant to the problem, so let's get back to it. What is the partial pressure of nitrogen in atmospheres at sea level, and what about oxygen? Okay, so we have two different methods of computing partial pressures. So we could either use this relationship, the ideal gas law, or we could use some sort of relationship down here, looking at mole fractions and partial pressures. Okay, so a good way to tell which one to use is depending on the information you're given. Ideal gas law, you need to know something about volumes, moles, and temperature. And we're not given anything about volume or temperature, so probably a good idea not to use the ideal gas law in this example. But we do have something about the mole fraction of gas. So that's what's given to us in these 78%, 21% stuff. So we'd know something about the mole fraction. So what we're going to do is use that form. So mole fraction of nitrogen, which is naturally found as N2. We know that's equal to 78% or 0.78 in fraction form instead of percentage form. Okay, and we also know that the relationship between mole fraction and partial pressure is given by mole fraction is equal to the partial pressure over the total pressure of the gas. Okay, so we're given Y, we're solving for P in 2, and so the only unknown, in air quotes that you can't see, is this total pressure. But we're told in the problem that we're at sea level. So assuming that we're at sea level on Earth, then we know that the total pressure is equal to 1 atmosphere. That is the definition of atmosphere, the pressure of air at sea level on Earth. Okay, so that means all we need to do to solve this problem is just rearrange. Okay, so partial pressure of N2 is equal to the mole fraction of N2 times the total pressure, which is equal to 0.78 times 1 atm, which is equal to, if you can do this in your head, 0.78 atm. Okay, so here's our answer for the partial pressure of nitrogen. And we do the exact same thing for oxygen. Okay, so now we have YO2 is equal to 0.21. And we know that the partial pressure of O2 is going to be equal to YO2 times the total pressure, which is 0.21 times 1 atm, which is equal to 0.21 atm. Okay, not too shabby, right?